All right, 4.3, proof in parallel. I'm going to start breaking up the videos into the sections. I just think it'll be nicer if the videos are shorter. It'll be easier for you to find out what you want. Yeah, just better than having like 20-minute videos. All right, so we've got two triangles here that Jada has dilated with center P and a scale factor of 2. All right, and she wants to show that all of these segments in ABC, so all the sides, are parallel to the corresponding segments in A prime, B prime, C prime. All right, so this is a rather important part of dilations, that when you dilate a line from a point not on the line, the resulting image, that dilated line, needs to be parallel to the original, the pre-image. The image and pre-image are always parallel as long as that center of dilation is not on the line. All right, so we're going to prove that. So Jada's claim as a conjecture would be that AC is parallel to A prime, C prime. AB is parallel to A prime, B prime. And then finally BC is parallel to B prime, C prime. All right, so this is a incredibly difficult proof. Well, I'm sorry, it's not incredibly difficult. It's not that bad once you see it, but it did take me like half an hour to finally get it. So, you know, I'm not expecting anyone to do this on a test, and of course, Regents would not expect you to either. But it is the only way to prove this this conjecture that dilated triangles by a point not on the shape will produce corresponding sides that are parallel. All right, so to really illustrate how you prove this, I'm going to use a different color. I'm going to use purple. So I'm going to draw two of my projection lines. All right, and you'll notice that when I do that, I've created two separate triangles. Let me really highlight that by making this purple as well. All right, I've created triangle, the large triangle, triangle P, C prime, B prime. That's this big triangle here. I've also created a smaller triangle, P, C, B. So what I want to prove here is that PCB is similar to triangle P, C prime, B prime. If I can show that these two triangles are similar, let me actually add this other side here. If I can show that these two triangles are similar, then I'll be able to show that I have corresponding angles that are congruent. If I can show that these two angles right here are corresponding, I then know by the corresponding angle theorem that these two sides have to be parallel. And you'll see that when I start to write things out. So, first thing I'm going to do is I'm going to label some side lengths as variables. So let's call this X, let's call this Y, and let's call this Z. And just to be very, very clear when I'm labeling X, Y, and Z, I'm going to write PC, the measure of PC is equal to X, the measure of CB is equal to Y, and the measure of BP is equal to Z. And you'll notice these are the three sides of triangle PCB. All right, so we know that because we've dilated by a scale factor of 2, if this length right here is X and this is my image, that must mean that the entire length of this line segment C prime P must be 2X. So I'm going to write that P C prime is equal to 2X. All right. By the same token, because we know that when you dilate a triangle, the resulting triangle is similar, I know that if this side CB is Y, that would make this side 2Y, since it's been dilated by a scale factor of 2. So C prime B prime is going to be equal to 2Y. And then lastly, if PB is Z, I then know that this entire line segment, and I should have been a little bit neater with this entire line segment here is going to be 2Z. So B prime P is equal to 2Z. And you'll notice if I make proportions now, if I write P C prime over PC equal to C prime B prime over CB equal to B prime P over BP, these are all going to be equivalent, making the triangle have sides, corresponding sides that are proportional. All right, if I substitute my variables back in, I get 2x over x equal to 2y over y equal to 2z over z, which really, when I simplify everything, I cancel out that x, cancel out that y, cancel out that z, I get my scale factor 2, so I know I have proportional sides. Knowing that I have proportional sides, I now also know that my corresponding angles have to be congruent. In particular, this angle, I'll write it out, angle PCB must be congruent to angle PC prime B prime. All right, so that's this angle here and this angle right here. All right, since I have these two corresponding angles that are congruent, I now know by the corresponding angle theorem I must have parallel lines. CB must be parallel to C prime B prime. All right, great. And yeah, that's the proof, and it's not a very easy proof to see. I really did not see that triangle for a while. It took me forever. I actually had to talk to my dad, who's also a math teacher. I tried it a couple different ways, and then we were working on it together, and we finally got this. Very, very hard proof, but it's cool that we can prove that we have parallel lines here. All right, and the same can be done if you want to extend lines this way, connecting A and A prime. You can make a multitude of similar triangles. I'll just show you with a black pen. If I were to extend this here, like that, I could then show that these two triangles, the small one here and the big one here, are similar, and I could get corresponding angles and show that AB are parallel as well. And then I've got similar triangles here as well. Very complicated diagram when I have all this stuff here, so I just wanted to show you how I would do one of them, but I would have to do it 3 times technically to show that all 3 corresponding sides are parallel. All right, so that's that. Question 3, in Jada's diagram, the scale factor is greater than 1. Would you have to change it if the scale factor is less than 1? Well, if the scale factor was less than 1, that would just take this triangle down further down here. Even if a scale factor is less than 1, the two triangles are still similar, so I would still be able to use the same proportions to create corresponding sides that are proportional. So I would know for a fact that I'd have some corresponding angles here that would make parallel lines. So even if the scale factor is less than 1, corresponding sides remain parallel. All right. And it's very important that we say that this point P is not on the triangle, is not on any of these line segments. Because if we look back, where is it? If we look back to well, if we look back to one of the previous, I'll just draw it real quick. If we look back to when we dilated, when we had a line like this, we had C and E here, and we dilated CE, and then we just made E prime that was like way out here. Well, since C was on that line that we dilated it, we got the same exact line. Lines that are right on top of each other are not considered parallel. So it's very important that when you are talking about corresponding line segments that are parallel, the center of dilation cannot be on the line. Because right here I just get the same exact line, which we don't call identical lines parallel lines. Parallel lines cannot intersect. So really the thing to remember from this, if you remember anything, is that when the center of dilation is not on the line and you dilate, that resulting line will be parallel to the original line. All right. Hope you guys have a great day.